And it's summertime edition, so that means we're doing a shorter show. Summer month, summer vacation, we're going to do some NPI and some new products. And then we're going to put some other videos throughout the rest of the week because we are on a summer schedule. We're going to keep doing shows, just did the show and tell, it was awesome. And we're still on the shorter shows.
And don't worry, fall is coming soon and break time's over. So
I like to say that.
I love saying that.
Yeah.
So yeah, we'll be back on some.
Yeah.
We'll change the schedule, but we'll be back to a longer show.
Yeah.
In a couple of weeks.
And then I'm working on some stuff. Prusa, call me. I'm trying to get, so for like 3 years there's been an article, Prusa, who's the printer company, also a person, has been saying open source hardware and open source is dead. I'm like, cool, great, get out of it. It's terrible, don't do it. But he said some things about patents and about how China is stockpiling all these patents, and this was like years ago now, and apparently, I guess they never used them, and there was never a patent lawsuit. But anyways, there was a bunch of things that just weren't accurate in this like death of open source thing. So I would like to get, he said he'd answer questions and send them over, and it's been a while. So then I just, there's an open source hardware thing coming in October, so I thought that'd be a good opportunity. And so anyways, I just put him on Twitter, because he hangs on Twitter. So I'm hoping that maybe he saw the show, and he clicks over and he's like, oh. So if you're watching here and you're into 3D printing and open source hardware and all this stuff, basically it looks like, in my opinion, is 3D printing for those kind of Prusa style printers that are a little bit more DIY, a little bit more expensive sometimes, depending on the model, blah, 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 blah. But one of the benefits is it was open source, and over time there's less and less of it open source. But anyways, it's a very tough business doing 3D printing, and based on what he was saying, there's nothing in there that has anything to do with open source. Why being in the printing business is hard, 3D printing business. So I just think if you're going to blame open source, tell us something that's real and useful, or don't. Don't throw everybody under the bus, because some of us are trying to work hard doing this. And if you want to make it so no one else does open source, that's fine. But maybe just say to be honest about it or something. I don't know. Okay. And I have no other way, because the city doesn't answer questions, so there's only one place that's left, because he's on Twitter saying, hey, look, we have a new product coming out. So I'm like, well, can you answer the questions about it? Anyways, that's my little tidbit of the show. So okay. On tonight's show, the code is more better BMP. I had the code and I just added the other piece.
Okay.
And then we're going to do some Ion MPI. This week it's Analog Devices, brought to you by DigiKey. Then we're going to do some new products. And this is going to be our show.
Yeah.
This is going to be our show. That's why I did that little thing.
Short and sweet.
Yeah. And in the background there's this sound. This is the Adafruit band.
Beep boop.
Coming in. On drums. Okay. All right, let's start with MPI. Look, we're really punchy. Okay. Let's first start off with. Ready?
Let's do it. Let's do it.
Okay, go.
On MPI.
All right, this is brought to you by DigiKey. Oh no! I think the background had the band on. I didn't.
Yeah,
lower it.
That's cool.
Oh no!
You want to go back and do it again?
I'm so sorry. Let me start that MPI segment over. See, this is why the summer shows are really tough, because I can fix it. But like,
yeah, it's playing music.
yeah, I was playing music. Now it's not.
Okay. Do you want to go through that again? Like, I'd hear it again.
No. I love it.
It's cool.
There's a scene in Forrest Gump where he's screaming at the Washington Monument, and it was like the most beautiful speech.
Yeah.
But the microphone got unplugged or something like that, and no one could hear it. So at the very end, he goes, "And that's why I didn't like Vietnam." And like, I was like, "Oh man, that's probably just happened here." I love it. I love it. Anyways, let's do it on MPI.
This is live.
Let's do it on MPI.
Okay.
Ready?
On MPI.
Ion MPI brought to you by DigiKey and Adafruit. Every week, Lady Ada finds the new product introduction. That's right, the NPI for you. This week, it's Analog Devices.
Yes.
Ahead of what's possible.
Okay.
What's possible.
All right.
And what's ahead of it?
That's ahead of it. So this is actually, Yeah, sometimes I see chips that I'm like, I probably have no use for it, but I know that somebody out there watching is like, this chip is exactly what I need for my next design. So the ADHV7410, and AD, analog devices, HV, high voltage. So this is a pretty cool chip. This is, so, you've used like op amps and stuff before, but have you used one that has 110 voltage rails, like plus or minus 55 volts, and 1 amp output current from like I won't say the emitter, but like the output port of the op amp? So this is like, I love op amps. I mean, but sometimes you're like, I just need to solve a problem and I want to use an op amp, but you don't want to add like a whole feedback section with like a driver and like current monitoring and over temperature stuff. Well, this chip does everything. It's not as cheap as your everyday op amp, but like I said, it can do up to plus or minus 55 volts. It does, it'll show you it has an SPI interface as well. Very, very high slew. And very high current output. So this is like great. Like I think they mentioned it's great for test equipment. So you can get, op amps from DigiKey for like $1 or $2. And you can see here, like they go up, often the voltage range and current range is like, maybe plus or minus 9 volts, maybe 5 volts, maybe 50 milliamps. And that's pretty standard because usually you're using your op amps for signal management. You have a sensor and you want to amplify it or linearize it, or you have a signal and you want to filter it. But then, like as mentioned, one of the examples was like driving a piezo. Like if you're driving a big piezo, you need like a very high voltage and a very high current. And like maybe you wouldn't use this in your final product, or maybe you would, but for test equipment and stuff, this is a beast, and I totally love this shit. I love this. It's so over engineered. It's so great. So inside, yes, it's an op amp. There's a couple of extra things. There's the high voltage, but there's a separate 5 volt. Inside there's a microcontroller, like a digital engine that has SPI. I'll talk about that in a little bit. There's a 5 volt reference for that. Internal LDO. There's sensors for fault management. So it's more than just a simple analog circuit. It's actually kind of an advanced chip, which justifies the complexity and the cost. Temperature sensing inside, interrupt support. I love the warning because it's actually, once you get past 24 or 48 volts, I actually have to warn you like, hey, 110 volts will zap you. It's a really big package. And we'll talk about that. It's actually mostly for thermal reasons. If you think about it, plus minus 55 volts at 1 amp, we're talking about like a huge amount of wattage that this thing can dissipate. And so they designed this so you can slap a huge ass heat sink on there. So most of these chips are not actually used. The die is big for heat dissipation, not necessarily because you actually need that many pins. There's only looks like about a dozen used pins on here. The output drive, can do up to plus minus 1 amp, 1.2 amp instantaneous, slew of 1400 volts per microsecond. This thing is awesome. I don't even know what I'd use it for, but somebody out there is definitely going to be using it. They even suggest what thermal system they suggest. Slew boost. So as you expect, if you're pushing an amp, plus minus 55 volts, slew is going to be a important part of how much current can you push and pull out of that output to reach the high voltages and the high currents. But basically, this whole thing is designed for that purpose. And to do that stably, there's also a section that the Deja didn't talk about where it talks about the compensation cap and the slew set. So obviously, as if you can have high slew, but that can affect your stability depending on your feedback path. So it is tweakable. Like they have a couple of default settings, like if you're using this voltage and about this slew rate, here's some settings we recommend, but it is tweakable. And they also have a spice model that you can use if you need to model it for your exact purpose. As mentioned, they really recommend hey, heat sink the hell out of this. I think they probably even recommend active heat sinking with a fan, not just a passive aluminum heat sink or a copper heat sink. But yeah, they talk about you can have copper pads underneath and on top. But the top of the chip is designed to have a heatsink mounted on top of it. It has an SPI interface. Now, say you can't set stuff like the gain is set externally, right? It's still an op amp, but there is stuff like shutdown, reset. You can check for error conditions and alarms and safety stuff. So I kind of you could always have that stuff external, but they do also have it internal to the chip. For example, here is a shutdown flag, which I thought was kind of nice. You can disable the entire circuit. Overcurrent, source, sync, over voltage, positive, negative, over temperature. So you can monitor your circuit as well. And best of all, it's in stock. Now, it's going to be, again, more expensive, but to be honest, for the amount of effort this saves you if you have a high voltage, high current system, $30 is a really good deal. If you're not building thousands and thousands of these, or if you need to keep your board compact, I could definitely see somebody saying, you know what? Take this. It's from Analog Devices. It's reliable. It's well designed. We don't have to worry about the rest of our circuitry working because this will just do everything all in one package. Slap a heatsink on it, and you've got your high voltage, high current analog output ready to go.
If it doesn't work out, if you do something else, it's not just it doesn't kind of work out. Doesn't it kind of really not work out?
No, I mean
this direction.
This kind of stuff. If you don't know what you're doing, easily you mess up your compensation path, everything goes pop, and you're dealing with months and months of debugging and dealing with it. Analog Devices, it's in their name. They're really good at doing analog devices. You want to do the digital part, you don't want to think about the analog part, just buy this part and it'll just work. You don't have to worry about it.
All right. That's really good INPI.
I was like, this is cool.
I'm glad we...
I hope to one day need to use this part because that's pretty sweet.
That is cool. High voltage.
High current.
I can think of lots of things.
Sensors, sensors, lasers. I can see there's a lot of weird ass anything that's physics or material science. Anything you're dealing with these, anything outside the microcontroller world where you're interfacing with the real world. These sensors.
I think laser. That we would need to do.
Yeah, like I said, there's times where I see devices where they're oh yeah, you need 64 volts and half an amp, and I'm like, where the hell, how, and they're oh, and you need to adjust it based on temperature, the voltage and current might change. I would just throw this at it and be done. Yeah,
I want to check this out. It's a cool part.
It's a cool part.
All right, that's INPI, everybody.
On NPI.
And this time.
Yeah. What is this, Robo Amadeus? What is?
I know what I did wrong.
No, you did nothing wrong.
I know what I did wrong in the meeting.
Never double down.
No, I know what I did wrong. Yeah.
You're wrong.
This is the thing. No one can ever admit they're wrong. So here's what I will. I love being wrong because it means I'm still able to change my mind. And the people who can't change their mind, they're actually the problem. Anyways, I'm not going to change my mind about that. Anyways, so what I did was I set it so when we go back to the video, it plays where we had just left off. It doesn't start at the beginning. Uh-huh. And while doing that, in the maze of user interfaces that we all navigate, yet another interface, there's a volume thing that you also have to do to turn the volume off of the video. So,
Question. Yeah. Do you think there'll ever be LLM AI that you'll just say, hey, here's some pictures, turn this into a show, and it'll just
I can do that now.
Yeah.
I can do that right now.
Here's all my shows, make me a new show, and here's what we're going to talk about.
I can do that now. It'd just take a while.
Yeah.
But I can do it.
Oh, interesting.
Yeah, I mean, my AI experiments sometimes come out of Brundlefly, but we could do it now. You could do it. Let's do new products. Yeah. Yeah, I mean, I could show you. It's yeah, 8 and number 5. You don't want to see 3 and 4. Okay, let's do new product, right?
Okay. Okay.
Alrighty,
it's
new
time for
products.
Some new products.
Yeah, so as usual, we're going to go to hit the product page.
Yes.
For
let's kick it with that tricolor to start. Okay. So we don't have the demo images yet because our photographer will be in.
But we have a new overhead.
But we have a new
which
overhead.
does work. By the way, Look at this.
Okay.
And then you see it's kind of sharp.
So this is such a big e-ink. I have to actually move this.
Yeah, you could zoom out.
I can zoom out. Well, I can also just do
Yeah,
this.
I'm glad I set this up. This is
great.
This is a hard.
I actually really like. I like this. Actually, I really like this one
Yeah.
more.
Yeah. Okay. Good.
Not a mistake. Great. Really big e-ink display. So 800 by 480, and you can see my hands for scale. This is the tricolor version. We had the monochrome version before. This one's tricolor, so you get black, white, and red. And what I love is like at this 7.5, it actually does. I'm not saying that the other one's really big paper, but it's like you get the pixel density and the pixel resolution. You're actually able to really show images. And they look very, very good. So it's not just like a little pixelated.
The color ink displays. So one of the projects that I'm doing is taking the news headlines and making images out of the news and making it look nice on ink displays because I don't want to read words. I just want to see a bunch of pictures.
Yeah.
So some days I look at the e-ink display news and I'm like, you know what? I'm going to skip today. Like it was like a bunch of needles and a bunch of things on fire and like a gavel on fire and like two gavels stuck inside each other. And I go, you know what? I'm going to skip today. Not really, but it's just a like emotional version of the news. It's like, here's everything going, you know, some days once in a while you see the skateboarding dog on there. It's like, what? And there's a skateboarding dog. But anyways, the screen looks great. You can finally do these projects.
That's the project we're going to use. Uses the standard 24-pin connector. So if you have one of our Think Ink driver boards, we always use the same connector. It plugs in directly. We have driver code. We actually have it in Arduino and CircuitPython, so you could use it with like a Raspberry Pi. You can use it with a CircuitPython board. You can use it with Arduino. So if you're using it with some other system, you'll need something with UC8179. But I really love this display. This is just the raw display, so don't forget you need something to drive it. But we have lots of drivers in the store that you can plug this into, and we're starting to collect a bunch of raw displays.
We're making it as easy as possible. The only reason you'd want to do other e-ink is if you don't like saving time.
Saving time
or
and money needs. Okay, and then let's go to the next one. And this is going to be go in the background.
Yeah.
Oh, do you want to go to the computer? Do you want to?
What do you want to do?
Go to the new product page, and we'll
you
formalize it.
Yeah, you have these. So this is the one that you showed, right?
Yeah.
And then you've got. You want us to show this?
Yeah, so can we flip to the computer from the overhead?
Yeah.
Yeah.
You want to show that?
Yeah, and I'll talk about that, and I'll jump back to the overhead again.
Gotcha.
Yeah. Okay, cool. So we also have a quad 3.52, 340 by 180 quad ink display. So the one you just saw was white background, black pixels, and red pixels. Okay, so now go to the overhead.
Yeah.
Thank you.
Yeah.
Sorry, I'm learning this too.
Wow.
So this is, I actually have it, kicked it up to my Feather e-ink. So this one, you'll see the
Let's go through all the modes.
Yeah, it takes, look, the more colors you have, the longer it takes to refresh. This is quad color and you'll see it's like, it does the red and yellow and then the black.
Yeah.
But it's cool because you get like 4 colors.
And it's not even that bright in here, by the way. Like I have the lights just for the filming. So let me see if let me put.
Yeah, nice.
See if I can even get it brighter. Kind of see.
It's pretty good.
And then it has its own light.
Well, I mean, it's good.
Is this the light on the top one? Is the top one light?
I don't know.
Right?
Yeah, now it is. There you go. Okay, so actually, let me unplug this. Okay, so then.
Let's show it even more.
So this is it's showing 4 squares, so you can see like the yellow, black, red, and white pixels. This is a different chipset. This is like the JD61179 or something. We have support for this also in Arduino, CircuitPython, and MicroPython.
Yeah.
Oh, that's big.
And then this is autofocus on the side. Is it autofocusing?
You have to click this.
Okay. And then,
There you go.
Okay,
and then it focus locks.
And then it focus locks. Okay. That's
Yeah,
good.
I have the focus lock on.
All right, that's really good. Now move the board down too.
Okay, then yeah. So the only thing about this, I will say, about this e-ink display is,
Looks good.
like this display has this connector, and see how the contacts are on the top? So this is the standard. For reasons I cannot quite comprehend, this one has the contacts on the bottom, which means you need to flip around the contacts in order contacts to use this display. And so when we ship this to you with a little like joiner adapter and a cable. And the cable flips the contacts over to be upright. Why did these e-ink makers decide to have the display contacts flipped? I don't know. It's totally a mystery because, again, it's very standard and they just decided to do the opposite. But thankfully, it's not too expensive and difficult to just flip it around. So when you buy this, just realize you can't plug the display directly into an e-ink driver board. You have to use this little joiner and the cable, and then together they will turn it into a flipper, and then you can use your standard Python or Arduino code to drive this e-ink display. Okay, cool.
And then is it time?
One more to go.
Okay, one more.
Yeah.
So let's go to this.
Okay, so but then we're done with the overhead.
Okay, great.
Okay, so the next one is the BMP 580. So last week we had the BMP 581, and it's a very nice precision barometric pressure and temperature sensor. Now we have the BMP 580, which is less expensive and it's less precise. That's basically the deal. It's firmware, software, pinout compatible. Everything is identical, except these just aren't as accurate or precise as the BMP 581s. Maybe that's okay. Like if you're using it for a drone or something where altitude, like you really want excellent altitude control, the BMP 581 is like going to get you the best performance because it has like plus minus 3 centimeter accuracy at like, about sea level and about room temperature. Whereas the BMP 580, it's like 50 centimeters. So it doesn't have as much precision. But if you're doing just like environmental measurement, the BMP 580 will work just fine.
And then for folks who, generally speaking, when it gets warmer, it gets which direction?
Basically, as you get outside of the sea level and room temperature range, it's just they have to calibrate these sensors, and they kind of pick like what's the most commonly used pressure and temperature.
You're probably in a room and you're at sea level.
Yeah, or like you're flying a drone and you're about at sea level, you're a little bit above sea level, but the temperature is about like, 72-ish degree or 25 degrees C. And it's around there that they're gonna calibrate the sensor to get the best accuracy and precision. Mm-hmm. But that costs money, and like not all sensors are
you don't need that. It's a good alternative.
Reproducible. Yeah, so basically the 581 is going to be the most precise. It's going to cost a little bit more. Maybe you don't need that. Get the 580.
Okay.
Great.
And then
now the star of the show.
Star of the show tonight, besides you, Lee Data, all of our customers, all of the robots that play music.
Yes.
All of the team members at Adafruit.
Yes.
Here is
dun, 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 the BMP 585. So this is the third in the series of the 5Xs. So all of these, again, are all code compatible. This is cool. We have an electron microscope going here. We can
yeah, well, we have an even higher resolution ones, but I just wanted to put that in.
Nice.
Yeah.
So this is a ported sensor. So the other ones, they're enclosed or they have a microscopic hole so that they can measure, ambient. But let's say you want to have this be underwater, or you want to have a tube that connects to an outside port, or you want this, again, maybe you're using this for like a drone or something where you don't want the sensor exposed to air, you would, or the whole body of the electronics exposed to air. And with this, you can connect a tube up to the port and connect a little O-ring onto it. And then can you go back up one, because this will show the port really well. Yeah, it sticks up, and you can see there's a little groove for an O-ring. You connect an O-ring. I tried to make a little bit of room around it for the tube. And then you can have the tube go out to anywhere and measure barometric pressure. And then the temperature would be for whatever air is closest to the sensor itself. And this has the same kind of accuracy precision as the BMP 580. But again, it's ported. And what's nice is it's a lot less expensive than other ported sensors, to be honest. Usually these are quite expensive. But for the accuracy and precision, you're going to get a very nice sensor. And I think this is maybe one of Bosch's first ported sensors. I don't think they made a lot of these. So I'm glad they came out with a variant that works with this.
Also, shout out to Bosch. Somehow I'm selling their sensor, looking at their sensor. You're writing code for their sensors. I use a Bosch microwave. I have a Bosch Dishwasher, and one of the tools I really like, only Bosch made it in Europe, and I had to get like a special thing. It's a saw thing. Anyways, Bosch. Go Bosch.
Yay,
somehow,
Germany.
Bosch is all up in my business all the time. Everywhere I go, I see Bosch.
Okay.
However, here's the one thing.
Yeah.
If anyone out there has a Bosch microwave, you have to hold clear and off and then the settings button at the same time if it goes into demo mode. Because if you just walk by it, it goes in demo mode. Whoever designed it, it instantly goes in demo mode.
To be fair, like I bump it with my butt, and I think I put it in demo mode by accident.
But like, when you just walk by and brush up against it, somehow we're just lucky enough where it just happens to hit the exact thing. So anyways, our little pro tip. We don't use a microwave then. we don't usually use microwaves.
But when we do,
we're just like, well, it's been in demo mode. I guess that's why it has never gotten warm. Yeah.
Okay.
All right. That's new products. Yeah. All right, that's our show because it's the summer edition, More Better BMP. We'll check out questions in the chats in a bit. We have to go take care of a kid. We have a babysitter, so we're going to go. More Better BMP is the code, 10% off in the Adafruit store all the way up until when I turn it off. And what's that?
I like the little drum dude.
Yeah. Okay, bye everybody. This has been an Adafruit production. Here is your moment of Zener.
Later. Have a good night, guys.